Hello and welcome to Office Hours. I'm Greg Yatman. Today, I am lucky to be joined again by not only Mehmet Yavuz, but also Dean Bubley. If you've seen previous episodes of either Slice of Celona or a previous episode of Office Hours, you'll know that we have Dean as our resident expert, analyst, wireless guru to join us from time to time to let us know whether we're on track, off track, or what's happening in the industry in general. So today he's joining us to speak about network slicing, the what's, where's, why's, when's of network slicing. But before we jump into that, let's define what it is. So with that, I will kick it over to Mehmet to tell us, what is your definition of network slicing?
Yeah, great question. And again, so nice to be here with you, Dean. Thanks for joining us. The network slicing concept is a very hot topic in 5G world. And there are a lot of discussions going about it. Not too many real applications yet, but the concept is very powerful. It's essentially a service provider or managed service provider or operator, whoever you want to call it, providing different slices of the 5G infrastructure, both hardware and software, you can think about it, to different end customers, right? Typical example people talk a lot about, which is honestly more related to traditional macrocellular network, is a mobile network operator providing different slices to different customers. For example, for an automotive company, an operator can give a slice. For a manufacturing company, the mobile network operator can give a different slice. And these slices may have different kind of characteristics, such as maybe low latency, ULLC, or it can be high bandwidth and so forth. The other aspect is the mobile device can request a certain slice. Like device can request the ULLC, ultra reliable low latency slice, or an EMBB slice from the network. So all those things need to come together for an actual commercial service that makes sense. And we'll talk about the private 5G use cases, what we are doing at Celona and so forth. But Dean, before we dive more into details of that, I would love to hear your take on network slicing.
Thank you, Mehmet, and glad to be back on the show again. So I view very differently slicing within a well-engineered, specific private network. We'll talk about that in a minute, versus the public network. And I'll be honest with you, I'm a bit of a slice skeptic on the public network for national deployments, partly because it really only comes into reality with release 15 and 16, but also because in the public network, whilst there are some applications, for example, you might want to segregate fixed wireless access on a given cell with a certain amount of capacity and quality versus the mobile broadband. Where it gets trickier is in the real world across a big network, national network. You'll have pockets of 5G, areas of 4G, indoor coverage constraints, and a whole bunch of other things that make some of the visions harder to realize. Whereas in a private network, it's controlled by typically an enterprise or maybe a service provider for the enterprise, so they know the characteristics, they engineer the coverage better, the capacity, and also importantly, in a lot of cases, they will be defining the applications and the SIMs. So there's no sort of tussle between, oh, I'm a gold user with a platinum application and you're a silver user with a premium diamond application, but you're roaming, and there's fewer parameters in the private scenario, whereas in the macro scenario, I think is more of a challenge. So I'm very interested in to be honest, it's not dissimilar in an enterprise setting to what is familiar on a LAN or existing corporate network, wired or Wi-Fi, where you've got VLANs, where the network manager can set priorities and so on. So it's a similar sort of setting because it's more controlled with fewer variables than in the wide area.
Absolutely. You're right on spot, Dean. And I totally agree with the challenges of network slicing at a national level, right, for a mobile network operator. But let's talk about private 5G, right? A deployment region, a certain area, and you have different applications. And We take the network slicing concept for the private 5G and make it really much more granular for all these different applications running in a private 5G. And what we do is we give the ability to the end customers to enforce strict SLAs for radio resources and isolating some of the network resources and providing KPI level monitoring and orchestration for all of these. And we call this microslicing, right? Our approach as Celona for this whole concept is microslicing. And at the end of the day, what really matters is for the devices and applications running in this private 5G network, how can it be guaranteed QoS? How can the traffic be isolated and tied to different VLANs or VXLANs in the network? How can the access and identity policy management can work together with the existing LAN infrastructure? So that's what we do. Our approach is very LAN specific. And at the end of the day, it's easy to manage and orchestrate, right? If a customer wants 10 megabits per second guaranteed uplink throughput for a set of cameras, they can just create a separate device group. They make a separate VLAN for this application, and that application can be defined as what is the computer vision server that's used, like a 5-tuple or DHCP marking, a simple kind of mechanism that the enterprise IT can manage, and you're done, right? You created a microslice for the IP camera application. You have handheld devices, you need a guaranteed latency for the applications running on there. You create a separate slice with a separate VLAN. And you can segment different devices based on their MAC addresses and so forth. So that's how we approach it, and we're getting a lot of traction so far in the market.
I think in that enterprise setting, the CIO roughly, they will know how many video cameras they've got around the perimeter. They know how many AGVs they've bought. All right, if it's slightly different, if it was a venue like where you've got visitors, but to be honest, most of the early deployments of private networks are where they are corporate-owned and issued devices and SIMs. It's cameras, it's robots, it's handhelds, these sorts of things. So the solutions people are designing for, they will know how many. There's never going to be more than 5 robots in that part of the factory or whatever it happens to be. So they can dimension everything, and they've got more of an idea as well of what the priorities are. What's the most important thing? What is the most safety critical thing? And that's going to vary depending on the location and the site. It could be very different to a warehouse which has full automation and no humans, to an airport where you've got vehicles driving around and passengers and baggage and regulation and compliance and security issues. And I think that at that point, someone is able to, if you like, take control of it, and having the tools to do that makes sense.
And the tools is the key part, absolutely, right? It needs to be simple to configure and manage. I mean, if there are hundreds of parameters, no one is going to be able to configure all of that. But if you give them 10 options, right? Saying, okay, these are your 10 micro slices that you can choose from. And then if it is a matter of selecting, okay, these are my devices, I want this kind of slice for that device and device group, and this is the throughput requirement that I have, guaranteed GBR, and boom, you're done, right? So that's the key.
And I think one thing that particularly jumps out at me is a lot of the private networks that I see, they start with one application. And I think there's going to be a really interesting discussion when a production network that's supporting one application wants to add in application 2, 3, 4, they will want to be certain that it doesn't break whatever application 1, which probably, to be honest, paid for the deployment in the first place. If you're put video cameras for security, for compliance reasons, that's probably paid for itself. The compliance department has justified the investment. And if someone else comes along and says, well, I want to run handhelds, or I want to run this robot, that it absolutely can't get in front of the cameras that you bought the initial implementation for.
Absolutely. And I think that's where the really deterministic QoS of 3GPP comes in, right? in 5G, you have both actually LTE and 5G, you have these different QoS classes, the QCIs or 5QIs defined by the standard that can give strict priority. And it can have a guaranteed bit rate, right? GBR defined. So you have all the abilities that comes with the 3GPP. And what we do is we tie these different slices, micro slices, to different QoS classes, QCIs and 5QIs. So you know the exact strict priority of different micro slices, and you know the guaranteed bit rate, and each slice comes with a guaranteed packet delay value and packet error rate, right? So those are deterministic, you're guaranteed. And of course, there's the best effort class always, right? The default. So anything that's not assigned to any of these micro slices get the best effort treatment.
I think that's also important in situations where you've got existing deployments of Wi-Fi, of different types and classes of Wi-Fi, as well as private cellular. It may be that half your you're not going to throw out necessarily all your old Wi-Fi cameras just because you've got some cellular ones, and so you perhaps want to sort of map them together or have an associated group or something like that. So I think that there's going to be a difference here between the what I call greenfield and brownfield deployment of networks, where if you're building your warehouse from the ground up, you can design in perhaps you make it maybe not all cellular, but cellular primary. Whereas other things you're going to be saying, well, I've got my warehouse and everything works well, but I want to buy these new AGVs that go indoors and outdoors, so I need to have them on cellular, and I put that on a separate group. Maybe with you have API links between your Wi-Fi platform and the cellular.
Yeah, very, very, very good point. And today, I mean, the way enterprises work is they put these devices into different VLANs, right? IP domains, and we kind of fit to that exact framework that you described. So today, IP cameras may be on certain VLAN. And then our customers, when they bring our solution, they can keep the same VLAN as it is. They can keep the same access identity management policies in place. And then they can tie one of the micro slices to that existing VLAN. I mean, that's the key, really, to work with the current workflow and the infrastructure and the LAN domain that these enterprises work with.
Presumably, you can also do this where you have a gateway. So if I've got a 5G gateway, let's say on a vehicle, but then that creates a little bubble of Wi-Fi, presumably you can address the devices, if you like, the second tier of wireless within that.
Yeah, exactly. Very good point. I mean, that happens with IoT gateways today. And you may have an IP camera and a sensor attached to a 5G IoT gateway. And what we really do in those cases is, in the 3GPP lingo, we create different bearers, right? Different QoS bearers, DRBs with the 3GPP term, for different QoS flows. And each flow can have a separate QCI or 5QI with the well-defined packet error rate, GBR, delay bound. And then you treat these two things as two separate microslices. It may be going through the same IoT gateway, but the end device is a separate IP device with a separate MAC address, and they can be in different device groups in the LAN infrastructure.
I think that's really important, because everyone thinks about the sort of, if you like, hybrids, where assumes it's like direct to the device connection. But I see a lot of scenarios with gateways, and it could be a LoRa gateway backhauled with 5G or 4G. It could be with Wi-Fi. There's lots of different permutations here, or even devices which have multiple radios. It gets even more complicated. But I think that we're going to start getting some of these second order considerations coming through as the sector matures.
Very true, very true. You cannot expect all those end devices to have a 5G module in it, right? So the gateways are key. But what's really exciting for us is to be able to extend the micro-slicing concept to those end devices, thanks to having these different QoS flows simultaneously going through the 5G airlink.
Okay, that's interesting. Because normally I'd assume that slicing just ended at essentially at the SIM. And so if you can actually address, almost like treating the gateway as the equivalent of a sort of network address translation box from a IP point of view, that's sort of quite interesting.
Yeah, with DHCP relay and so forth, that's something we do, but also the different QoS flows can be handled. So yeah, well, I would love to talk to you some more. Maybe we can have a whiteboard sometime to go over some of the details.
Or maybe that's another episode. I think for today, we've sliced up network slicing as much as we can in our allotted time. I thank you both for your time as usual. Dean, we always appreciate when you join us. If you, our listeners or our viewers, have not already Googled Dean Bubley or Googled Dean Bubley, disruptive wireless or analysis.
Disruptive Dean on Twitter as well.
Disruptive Dean. Check him out. Some of the topics we've discussed both in this episode and previous episodes in Slice of Celona and Office Hours will be in articles that he has either written or will write in the future. So treat yourself to that. In addition, please do look back into our repository of Office Hours where you'll find the greatest hits of Mehmet Yavuz. He's got plenty of content there, and also some of the webinar content we have in our resources where Mehmet has been a presenter. But in the meantime, we hope you enjoyed our network slicing episode and that you come back again to Office Hours. Until then, take care, have a great day, and thank you both for your time.
Thank you.
Thank you.
Thanks a lot, Greg. Thanks, Dean. Bye.